Hey everyone. In this video, I wanted to talk a little bit more about space curves and the parametric functions that we saw in the last section, but specifically with regards to velocity and acceleration, as well as, I guess, position. So you can do these pretty easily in CalcPlot3D. In fact, it's kind of built in very nicely. So again, if you want to draw a space curve, then you can click Add to Graph, Space Curve. So I will use kind of the basic one here with cosine, sine, and then let's just do 0.2t to have it a little more spaced out. So we'll graph this so we get a nice little helix. And here we've got time going from -10 to 10. So we're going from height -2 to 2. So that seems pretty nice. And the way that you can both move along your helix, but also see velocity and acceleration is by clicking on the trace. So this one is a little hard to see. I will rotate this a little bit. So right now, R, that's your position. It's 1i, so it's going exactly 1 in the x direction. That's that blue arrow going right there. Your velocity is 1j, so a little bit in the y direction, and then plus 0.2k, so a little bit up. So if I just rotate this around a little bit, this is the one in black right here. So you can see it going straight in the y direction, but then with that little bit of vertical change. And then lastly, we've got the acceleration, which is in green, kind of pointing back toward the origin there, -1i. The first one, the position vector, will always start at the origin and then point to whatever point you're at. So I'm just going to move this along a little bit. So notice the blue here is going exactly from the origin out to my point on the helix, whereas the velocity and acceleration vectors are both starting with their tail at the point on the curve, and then their tip is pointing in whatever direction. So you'll notice that as you kind of move along, let's start down here and just have it animate. So as you move along, the position vector just kind of winds directly along the helix, whereas the other two, again, kind of point out from the curve. The acceleration is always kind of pointing back toward the z-axis, as you can see, whereas the velocity is just kind of shooting out as if you were to release something in flight as you were traveling along the helix. Where would it go? It would go exactly in the direction of that velocity vector. The acceleration points inward primarily because that is what's actually making you turn, right? So it's making that velocity vector turn back inward because acceleration is how velocity changes, and this is what caused you to kind of go around circularly around that z-axis. The acceleration is always pointing you back toward the z-axis to ensure that you circle around it. Okay, and so at each step, you can see the exact vector for each of these, but obviously like you'd have to use derivatives and integrals and stuff if you wanted to get the formula in general. It's not giving you the formula, it's literally only giving you the value at a specific point, right? And that point being governed by whatever time you're at as you travel along your curve. So that is a way to view velocity and acceleration and also get kind of some nice physical intuition for why they look like that as you move along a curve. So hopefully that helps a little bit with visualizing these ideas that you're so familiar with from Calc 1 in a Calc 3 context.